Okay, so we will be continuing with our binary search playlist. Now, this is the part of the Strivers A to Z DSA course. In case you haven't checked it out yet, there's a link in the description. Make sure you check it out. So before starting, hey everyone, welcome back to the channel. I hope you guys are doing extremely well. So the problem that we're going to solve today is finding out the median of two sorted arrays. Now, this word is very important, sorted, because that is what will help us to solve this problem. Now, you can be given two arrays of equal size. You can also be given two arrays of different size. Like in this example, you can see this array is of size 6 and it is sorted. This array is of size 4 and it is sorted. Now, what you have to do is, you have to find the median of these two sorted arrays. So, what you have to do is, you have to take both of the sorted arrays and you have to combine them. So, if I combine them, what I get is 1, 2, 3, 3, 4, 6, 7, 10, 12, 15. What is the total number of elements? The total number of elements in this case is 10. Why? Because n1 was 6, n2 was 4. So, the total number of elements is 10, right? So, if I try to find out the median, can I find a median of 10 elements? I cannot. Why? Because if I stand over at 4, there are 4 elements on the left, there are 5 elements on the right. If I stand at 6, there are 5 elements on the left, 4 elements on the right. So, there is no specific median, because median means on the left and on the right, there must be equal number of elements. Now, this is not in this case, this is like 5 and 4, they're not equal. So, can I say the median will be somewhere between 4 and 6, because if I take somewhere between 4 and 6, on the left there are 5, on the right there are 5, which is equal. So, I can say that the median is somewhere between 4 and 6. So, it's like the middle of 4 and 6. So, 4 plus 6 by 2. 5 is the median in this case. Now, over here the point to notice was the total number of elements was even. That is why it did not have a specific median. But what if I take this example? There's like 3 elements, there's like 2 elements. So, what is the total number of elements? Can I say that the total number of elements in this case is 5? I can. So, if I try to combine them in this time, what will I get? If I try to combine them, I'll get 1, 2, 3, 3, 4. If I ask you what is the median, can I say this is the median? I can. Why? Because there's like 2 elements on the left, there's like 2 elements on the right. Thereby, the median is pretty simple, the midpoint. So, in case of the total number of elements being odd, it's very simple. In case the total number of elements is even, I have to consider 2 elements and I have to take the middle of it. Got it? Now, this is what we have to find. We have to find the median of 2 sorted arrays. So, both the previous solutions were taking a BGO of n1 plus BGO of n2 time, and yet we did get a time limit exceeded when we tried to submit it. Now, this is a linear time complexity. And if we have to optimize it, what can be the optimization of it? Somewhere around square root or somewhere around logarithmic. That is how we can optimize this. Square root I will not consider as of now. I'll consider logarithmic. Why? Because of this thing, sorted. We know in sorted stuffs, we probably can apply binary search. And binary search is an algorithm which works in logarithmic time. So that is where the intuition comes in from, because the linear did not work and it is given as sorted. Let's start thinking of a binary search solution. And if it doesn't work, then we can think of something else. But the first hit point should be binary search solution. So what I've done is I've taken 2 arrays. And if you sum up their elements, that is 10. The total number of elements is 10, which is even. So, let's first understand the binary search solution in terms of even number of elements. Once you've understood the concept, then we can easily switch to odd. Once you've understood for even, it's very easy to switch to odd. So, as of now, you might be thinking, but how do we apply binary search? Because till now we have seen in an array, we did a search, we used binary search. If the search was on answers, we did on binary search. But over here, how do we apply binary search? First thing, we have 2 sorted arrays and we're trying to merge them into a 3rd sorted array. And in doing so, we're finding out a median, right? If we try to draw a symmetrical line on that median, on the left, there are 5 elements. On the right, there are 5 elements. Notice this symmetry. Okay, next step. Out of these 5 elements, how many are coming from array 1? Can I say 1, 3, 4? So there are 3 elements from array 1. Agreed? And there are 2 elements from array 2, right? On the right, there are 3 elements, the rest 3 are on the right, and the rest 2 are on the right. So this is where we'll start our binary search. We will try to formulate the correct left half. We will try to formulate the correct left half. If we are able to do that, we can actually find out the median. How? Let's understand. Imagine you formulated the correct left half and you formulated the correct right half in hypothetical scenario. Then the median will be 4 plus 6 by 2, isn't it? Right? So our task will be to figure out, okay, 3 elements from array 1 and 2 elements from array 2 will formulate the correct left half. Because one thing I'm very sure is the left half will be this itself only. Will be this itself only. It cannot be anything else. It cannot be anything else. Right? How to do this? Let's understand. Let's do the strategic linear search and we'll try to do it, build on it. So, we're trying to build the left half and we're trying to build the right half. So, imagine I say you from array 1, because we know we need 5 elements. What's the linear search? Like, where does it start? Maybe pick up 0 elements from array 1. I'll pick up no one from array 1. I'll pick up no one from array 1. If I pick up no one from array 1, what will happen? In that case, I'll have to pick up 4 elements from array 2, because how many do we need on the left? We need 5. So if I pick up no one from array 1, there are like 4 elements from the left. Array 2, I have to pick up every one of them. Even if I pick up every one of them, I cannot get 5 elements. Something I know for sure is, if I pick up 0 elements from array 1, it's not possible. Like 0 elements is not possible. Like fine. Can you pick up 1 element from array 1? He says, why not? So I'll pick up 1 element from array 1, which is 1, the first. How many do we need to pick up from array 2 then? We need to form 5. We need to pick up 4 more. So what I'll do is, I'll end up picking 2, 3, 6, 15. I'll end up picking 2, 3, 6, 15. Right? What will be on the right? The remaining, very simple. 3, 4, 7, 10, 12. So what I've done is, I've said, pick up 1 from array 1. I've done this. And pick up the remaining. So there were total 5. The remaining 4 got picked up from array 2. Now, can I say this is a valid configuration? I cannot. Why? Because if I try to sort them up, it'll be like 1, 2, 3, 6, 15. And on the right, it'll be 3, 4, 7, 10, 12. Is this a sorted array in any means? Even if you draw symmetry, this is not. Why? Because 15 is greater than 3. That cannot be a sorted array. That cannot be a sorted array. How do you recognize that? We'll come to that afterwards. So you'll come to that afterwards. But as of now, this cannot be a valid symmetry. Perfect. Let's go to the next. Next is pick up 2 elements. Okay, let's try to pick up 2 elements. It'll be like 1, 3 from this. Perfect. So how many are remaining? There were 5. We picked up 2. 3 more. Let's pick up the 3 more from the array 2. Picked up. That's the left portion. What will be the right portion? All the remaining elements. 4, 7, 10, 12 and 6. Oh, sorry. My bad. 50. Is this a valid configuration? It isn't. Why? 1, 2, 3, 3, 6. If I try to write them in a sorted order, and this will be 4, 7, 10, 12, 15. Again, the 6 is greater than 4. This is not a valid symmetry. This is not a valid symmetry. Why? Because 6 is on the left. So 2 is also not possible. Perfect. So 2 is also not possible. What is your next job? The next job is maybe pick up 3. Maybe pick up 3. So if I pick up 3, it will be 1, 3, 4. So if I pick up 3 from the array 1, if I pick up 3 from the array 1, how many from array 2? 2 more. Pick up 2 more. That's 2, 3. How many will be left from array 1? It'll be like 3 more left. So 7, 10, 12. And over here, it will be 6, 15. Is this a valid symmetry? Let's look at this. If I try to write down them in the sorted order, it's like this. And this is like 6, 7, 10, 12, 15. And if you carefully notice, this is a valid symmetry. Because 4 is lesser than 6 and all of these are in the sorted order. So this is a valid symmetry. So what we figured out was, if I pick up exactly 3 elements from array 1 and the remaining from array 2, we get a valid symmetry. You can try out picking 4 elements as well. Try picking out 4 elements. So try picking out 4 elements. It will be like 1, 3, 4, 7 from array 1. And the remaining will be just 1 more we require. So that's 2 from the array 2. And on the top, it will be 10, 12. and the remaining will be 3, 6, 15. Again, if you try to write them down, 1, 2, 3, 4, 7, this will be 3, 6, 10, 12, 15. You carefully observe. This is also not a valid symmetry because 7 is greater than 3. It should have been on this portion. This should have been here. It's not a valid symmetry. This is also not a valid symmetry. Picking up 4 elements is not possible. So what did we notice? Picking up 0 not possible. Picking up 1 not possible. Picking up 2 not possible. Picking up 3 possible. Picking up 4 not possible. Picking up 5 not possible. And that is the max you can pick up because, there's like 6. 6 is also not possible. So the only thing that is possible is 3. Something we observed is there will always be one valid symmetry where you definitely know 3 from here, 2 from here. There cannot be any other configurations. Got this? This is the first thing you have to understand. How many to pick? If you've understood this, then we'll move to the next. So till now we know one thing, that this problem is being solved on the basis of symmetry, where we decide 3 elements from the array 1 and 2 elements from array 2. This is what we have to get to. After that, we'll decide how to find out the median. But that is our first step. But how do we figure out that it's a valid symmetry or not? Imagine you're picking up 4 elements from the array 1 and you're picking up the remaining 1 from array 2. So this is the left portion. This is the right portion. This is the array 1. If you carefully notice, this is the array 1 and this is the array 2. How do you determine that this is a valid symmetry or not? It's very simple. You know one thing for sure. This is array 1, so this will be sorted. This is array 2, so the second line will also be sorted. In order for this to be a valid symmetry, this 7 is on the left. This should be smaller than this 3. This 7 should be smaller than this 3, which is not the case. And this 2 should be smaller than this 10. This 2 should be smaller than this 10, which is not the case. That means the 7 should ideally would have been here. Ideally should have been here, right? That is why it is not, because 7 is greater than 3, so it cannot be on the left. We do not check for this, we do not check for this, no need, because it's from the same array. We just check cross. We just check cross. Now this is where we pick up 3 elements from the array 1 and 2 elements from the array 2. Now this is a valid symmetry. Why? Because this 3 is smaller than 7, which is a valid, and this 4 is smaller than 6, which is valid. Hence, all the elements on the left are smaller than all the elements on the right. Why? Because we already checked for, this is an array 1, so it is sorted. This is array 2, this is sorted. Just need to make sure that these cross guys are smaller. If that is, all the elements on the left are smaller than all the elements on the right. Hence symmetry. Hence symmetry. Got it? Next. What if we pick up 2 elements from the left? 2 elements from the array 1 and 3 elements from the array 2. There's 3, there's 15. That's smaller. Perfect. Perfect. But the cross 6 is not smaller than 4. 6 is not smaller than 4. Hence, not possible. Not a valid symmetry. So we have also understood how do we figure out it's a valid symmetry or not a valid symmetry. So let's quickly do a recap. Till now we have done 2 points. The first one is the binary search will be on the basis of symmetry, where we determine how many from array 1 will be on the left, how many from array 2 will be on the right. And the second one, how do we determine if it's a valid or an invalid symmetry? We just compare the cross. If they are smaller, if the entire left is smaller than the entire right, it's a valid, otherwise not. But now the question arises, but how do we figure out the median? How do we figure out the median? Very simple, I'll tell you. Now this is a valid symmetry. Over here we know these many elements from array 1, these many elements from array 2. How do we figure out the median? So let's probably call them as L1, L2, right 1, right 2. So L1 means left 1 from array 1, L2 means left 2 from array 2, R1 means right 1 from array 1, R2 means right 2 from array 2. Okay? How do we find out the median? Let's go back to the originals, sorted arrays. How do we figure out the median? We took the greatest of all on the left. We took the greatest of all on the left, and we took the smallest of all on the right, and we added them and divided by 2 to get our median. Same thing we do. We know one thing for sure. This array is sorted. So what will be L1 will be the greatest over here. This array is also sorted. So 3 will be the greatest. So what will be the total greatest? The greatest on the left will be max of L1 comma L2. Quite simple. And what is the smallest on the right? Because that is what you need, the smallest on the right. The entire thing is sorted. So R1 is the smallest on the top and R2 is the smallest on the array 2. So plus minimum of R1 comma R2 divided by 2. This is how you'll get the median. We'll come to odd afterwards. But as of now, please focus on understanding this particular even thing. Once you've done this, odd is going to be very simple. So till now, we are following the symmetrical pattern to solve this problem where we are figuring out that we need 5 elements on the left. How many from the array 1? How many from the array 2? So if we just focus on array 1, just on array 1. Why? Because if I can determine how many from array 1, the remaining, because total was 5. So if I pick up 3 from array 1, we just need 2 more from array 2. So from array 2, we will know how much. So let's focus on array 1. How many from array 1 should be our focus? How many from array 2 will automatically be determined? How many from array 1? 0, not possible. 1, not possible. 2, not possible. 3, possible. Will I go and do a linear check? If we do, we fall back to the linear complexity. So we did not. But can I do a binary search? 4 not possible, 5 not possible, 6 not possible. Because that is the maximum elements I can take. Now, I can't see a binary search pattern. Because binary search is technically like not possible, not possible, 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 possible. I can't see a binary search pattern. But I'll tell you how to apply binary search. I know one thing. In the array 1, I can pick up no one or I can pick all of them. In the array 1, I can pick up no one or I can pick all of them. Now, how will I determine whether to go left and eliminate right? Eliminate right by going left or go right by eliminating left. That is what you have to figure out. Basically, if you are somewhere between 4, how do you eliminate the right half? Saying 4 and beyond 4 is not possible. Go and search on the left. How do you do that is what you have to focus. For that, I'll come back to this example, and this example. Let's come back to that. So I'll write over here I'm picking up 4 elements from the left. Over here 3, over here 2. So I know this is a possible answer. This is the left half. This is the right half. How do we determine this is the right half? Let's see. We're having 7 and that's greater than 3. Hence not possible. So any case, this is known as L1. If you remember L2, R1, R2. Any case, L1 is greater than R1. That means high will be eliminated. Got this? High will be eliminated. We cannot take the right. Not possible. We need to reduce the value of 4. 4 is not possible. Reduce the value of 4. This is possible. This is always possible. So we stop there. Stop there. What about if it's a smaller value? Let's look at this. In this case, the 6 is greater than this, which is the L2. Let me write that again. L1, L2, R1, R2. If L2 is greater than R1, in that case, the left portion will be eliminated because if 2 is not possible, you cannot do for small elements. So these will be the conditions for binary search. This is how you determine whether to reduce 4 or whether to increase 2. These will be the conditions. Quite simple. Just ready observations and we're done. So I've said to you about the thought process. Now what I'll do is I'll do a dry run by taking couple of sorted arrays so that the thought process gets into your head, and after that we'll move on to the code. So the first question that I'll ask you is, in the example that we were taking till now, we are doing a binary search on an array of size 6, right? In order to determine how many elements will be fitting the symmetry. And we figured out that 3 elements were fitting the symmetry. And we were doing a binary search on a 6 length array. What will be the time complexity then? Be logarithmic of 6 size because we are doing a binary search on a 6 length array. So, will it be better if I do a binary search on the smaller array? Because the search space is just 4 elements over here. So, the time complexity will be logarithmic of 4. So, ideally, I should never do a binary search to determine how many from the longer array. Rather, I should do a binary search to determine how many from the shorter array. If I do that, time complexity will be lesser. So I know one thing for sure is I need to do a binary search on the shorter version of the array. Now, if I try to combine them, we'll have 1, 2, 3, 4, which is from here, and we'll have 7, that is 1 element from the array 1. And at the end, 7 and 9 is what we will take, right? This is how it looks like. So we know that we have to do a binary search on how many elements we need from the smaller array. So in this case, I can say maybe I'll not pick up anything, and that will become my no. And what will be the value of high? Can I say my high will be the maximum that I can pick up from that array 1, which is n1 in this case, and that's basically 4. Because 4 is the maximum number of elements that I can pick up from this particular array, right? Let's try to do a binary search. First time when I try to do a binary search, the mid 1, why am I calling it as mid 1? Because from array 1, right? So I'm saying pick up 2 elements from array 1. So I'm saying pick up 2 elements from array 1, which is basically over here, mid 1. Okay. So if I'm picking up 2 elements from array 1, how many will I pick up from the array 2? In total, I need 5. 5 minus 2 will be 3, so I'll pick up 3 from array 1. 3 from array 2 rather. 3 from array 2. So it will be pointing to index 3. Perfect. So if I try to segregate them, can I say 2 from array 1, which is basically 7 and 12, and 3 from array 2, which is basically 1, 2, 3. And can I say from the right, it will be 14, 15. Point to observe is mid 1, index is pointing to 14, and 4, 9, 11, and mid 2 index is pointing to this. And if you remember, this was called as L1, L2, R1, R2. Is this a valid symmetry? No, this is not a valid symmetry. How did you figure that out? Because L1 is greater than R2. And let's quickly go and check out the condition. L1 greater than R2. The high has to reduce, because this is not possible. This is not possible. High has to reduce. So what will you do? You will go back and you will say this is not possible. So the entire right half is not possible. Hence, you trim off the 2 to 4th section and you will be over here. Perfect. This is what you'll do. Now, I'll quickly erase this off so that we have better clarity. Perfect. Done. So you're standing at 0 to 1. Anything from 2 to 4 is gone now. What will be the mid? This time the mid will be pointing to 0. So I'm saying I'm not going to pick up anything. The mid one is pointing to 0. What will be mid 2? Mid 2 will say I'll pick up 5 elements from you. So point to observe again. Mid 1 is at 0. And where is mid 2? Over here. That's 5. Now try to segregate. On the left of this, there is no one. There is no one. Remember this, there is no one. So there is no one from array 1. And 0, 1, 2, 3, 4, 9. Is it? No, sorry, my bad. 1, 2, 3, 4, 9 from array 2. And on the right, 7, 12, 14, 15, and over here, 11. So again, if I have to write down the indexes, this is mid 1, this is mid 2, and this is R1, R2, L2. You don't have an L1. Remember, if you don't have an L1, since this is your left portion, you always try to take a smaller values because it's not there. And you want to compare if it is smaller. So just take a smaller value. If there is no one on the left, you just take a smaller value. It doesn't matter. Just take a smaller value, absolute value, so that the comparison is true. Okay. 8 mean lesser than 11. True. 9 lesser than 7? No, not true, not possible. So by taking 0 elements from array 1, it's not possible. Which is this case? Let's write down this case. L2 is greater than R1 is the case. Let's check out. L2 greater than R1. So you eliminate. Yes, you eliminate. And you say 0 is not possible. Eliminate this half. So you eliminate this. And the low now points to this. So please omit this again. Amazing. Perfect. What's the next thing? Okay, before that, let's quickly erase this. What's the next thing? We need to pick up one element. So the mid will also be there. So your mid goes at this. Will be mid 2. So if it is 1, this will be 4. So mid 2 will be here. Perfect. Let's try to again segregate them. So what I'll do is I'll do a segregation. If I do a segregation, it will be 7 on the left and 1, 2, 3, 4 on the left. And let's write the 7 properly. And over here it will be 12, 14, 15, and a 9 and 11. So what you're basically doing is, from mid 1 you're taking everyone on the right, from mid 2 you're taking everything, and on this. Simple. So can I say this will be mid 1, this will be mid 2, and this will be L1, L2, R1, R2. And if you carefully observe, this is smaller and this is smaller. Valid configuration. One element that you have to take. What will be your answer? Can I say L1 will be array 1 of mid 1 minus 1? That's what L1 is. L2 will be array 2 of mid 2 minus 1. Can I say this? I can. What will be R1? R1 will be array 1 of mid 1. And what will be R2? R2 will be array 2 of mid 2. Because mid 1 is pointing at mid 2 and the previous elements are there. In case there doesn't exist a previous element, or in case this doesn't exist, you'll try to take these values as intermean because they do not exist. If on the right they do not exist, because you always check for smaller, greater, like in this order, you always check for this order. So you'll always take this as intermax if they do not exist. And what will be that case? When you take all the elements, in that case there will be no right. That you take intermax. On the left, if there is nothing, you take intermain. Got it? So that's it. I have L1, L2, everything. You know the formula. What is the formula? The formula is max of L1, L2 plus min of R1, R2 divided by 2.0. This is only valid if the total number of elements is even. What if it is odd? Let's now jump into that. I might be thinking, what about odd elements? What I've done is I've taken an array where we have 2 and 3, so the total number of elements is 5, which is odd. Now, I cannot have a symmetry like this that will take away 3 from the picture. So there are 2 ways to do it. Either you can form a symmetry by saying 2 elements from here and 3 elements from here. That's one of the ways. Or you can say is, I'll take a symmetry by taking 3 elements from the left and this. And this is very simple. If you want to do a symmetry, like I'll go ahead and do a symmetry like this, where I say I'll have a bit more elements on the left and slightly lesser. So what is the total number then? It's like n1 plus n2 plus 1 by 2. Why? Because 2 plus 3 plus 1 is 6 by 2. That will give you 3. So I'll have 3 elements on the left and I'll try to make 3 elements. Will the formula for median change? Yes, it will obviously change. Let's look at this. In this case, you have 1, 2, 3. So you have 1, 2, 3. So you have like 2 and 1, 3 from the left. And you have 4 and 4 from the right. So what's your median? The median is 3. In this case, the formula will have median as max of L1, L2. That's your median. Very simple. You just have to decide that your symmetry will be either you can take 3 elements or 2. That's your choice. If you decide to take 2 and 3 on that side, then the formula will become for median min of R1, R2. Then you'll take from the right. I'll go with this. Why do I go with this? Because this formula will be valid for everyone. Because even if I have 10 elements and I do 10 plus 1 by 2, that still says me the symmetry, I need 5. Even if I have 5 elements and I do this, it still says 3. So the formula is valid. So the formula will be, how many will be on the left? n1 plus n2 plus 1 by 2 minus, this is the number of elements I need on the left. On left. That's it. This is what I'll work on. So even if it's 10, I need 5 elements on the left. Even if it is 5, I need 3 elements on the left. So it works for both of them flawlessly. And everything stays the same. So I'll be writing the code in the code editor directly this time, not on the iPad, because it might get a lot messier on the iPad. And on the code editor, I'll be writing it on C++. From the notes, you can find the Java, Python and JavaScript codes as well. And you can open them on the parallel. And one thing, I'm writing like simple while loop, if else conditions. So you will be able to understand even if you don't know the language. So don't worry about that. So the first thing that we'll do, we'll take n1, that's a dot size. I'll take n2, right? That's the first thing we'll do. What is the next thing? I know one thing for sure. If n1 is greater than n2, I always want to perform the binary search of the smaller array. So maybe just again call this function so that it just swaps it. Because I want to make sure that A is always the smaller array. The first array is always the smaller array. Perfect. The next thing I'll do is I'll say low to be 0 and high to be n1 because that is what I'm looking for. After this, I'll go ahead and do the same condition that we have been doing throughout. After this, I'll take the mid one because the middle in the first array to be low plus high by 2. After this, I'll figure out the mid 2. What will be mid 2? The number of elements that I require on the left. How many do I require on the left? You just now saw we figured out the formula. n1 plus n2 plus 1 by 2. That's how much we require. So on the left, whatever is required minus mid 1 is what it will be. Now I need to assign L1 and L2. So maybe initially you can do is you can keep them as int mean just in case they are not there, and L2 as int mean just in case, and R2 and R1, and you can keep them as int max in case they are not there. So we have given default values to L1, L2, R1 and R2, but now we need to assign them. Let's come back to the iPad. So mid 1 is something which is pointing to R1 and mid 2 is something which is pointing to R2. And one place before mid 1 is L1 and one place before mid 2 is L2. But you need to be sure about checking their places as well. Imagine you're taking this array, like just in case, and then like you want to pick 6 elements from the array 1. So mid 1 is going to be 6, which is a hypothetical index in this case, which is an hypothetical index in this case. So that index might not exist. So always make sure if mid 1 is lesser than n1, then only you will go ahead and say R1 will be taken from array of 1 and mid 1. If mid 2 is lesser than n2, then only R2 will be taken from B of mid 2 because otherwise that index doesn't exist. If mid 1 minus 0 is, minus 1 is greater than equal to 0, then L1 will be taken by mid 1 minus 1, otherwise they do not exist. If mid 2 minus 1 greater than 0, then L2 will be taken from B of mid 2 minus 1. That's it. Once you have done this, when can I say that they are technically a possible solution? If L1 is smaller than R2 and L2 is smaller than R1, that is what I'll write. If L1 is smaller than equal to, very important, R2 and L2 is smaller than equal to, again L2 smaller than equal to R1, then this is possible. I just need to check if the total number. So what you can do is maybe you can just write n equal to n1 plus n2. So if n is odd, in that case the answer will be max of L1 comma L2. That's very obvious. Else the answer will be, again you have to do a lot of typecasting. Max of L1 plus L2 plus min of R1 comma R2. You typecast it into double and after that you do a 2.0. That's it. Else, if, what are the conditions for high? L1 greater than R2. L1 greater than R2. In that case, high will go as mid minus 1. Else, low will go as mid plus 1. And you can just give a dummy 0 just because it has a double return type. So you have to give a dummy return over here. But ideally, in all the cases, it will be ending over here. So I'll quickly go and run this and see if it is running fine. So make sure that this is mid 1 and just make sure that the typecasting is done correctly. I'll go ahead and run this and see if it is running fine. I hope it does. It does. Let's quickly submit this and see if it is running. It will. So what will be the time complexity? We are doing a binary search on somewhere a size of n1, where we're making sure that the n1 is the smaller size. So according to the problem, minimum of logarithmic of n on m. So whatever is minimum will be our time complexity. Are we using any extra space? No. The extra space is big of 1. We're not using any extra space. And this will be the most optimal solution. So I hope you've understood the brood, the better, the optimal, the entire thought process, the intuition and everything. Just in case you have. I have a lot of energy still now. Like this video took me I think around 2 hours because I was spending a lot of time making sure that everyone who watches this video understands everything. So in case you're still watching, please make sure you like this video, and if you haven't checked out our Strivers A to Z DSA course, there's a link in the description. Make sure you check it out, and if you haven't followed me on Twitter, Instagram, LinkedIn, all the profile links will be in the description. With this, I'll be wrapping up this video. Let's finish some of the video. Till then, bye-bye. Take care.
Whenever your heart is broken.